Assalamualaikum. My name is NATIRAAH and my metric number is 820817C4. Introduction. Statistics, the study of many numerical data used to understand data and efficient planning of statistical research in any field and study. The mathematics used summarize, analysis, and interpret group member for observation. For discretion statistics, make use of graph, table, chart, and other statistical tools to generalize or to descriptions and content phenomenon. Inferential statistics is used to test generalization myth. It evaluates extracting and validating facts and figures for the purpose for decision making. 1.0 Data description. We have seed available for the data sets. This is liter per hundred, kpl, cylinder, horsepower, rates, and brand. Besides on the data, we selected three important data, mainly liter per hundred, kpl, and brand, to create a new data set. With the 115 variation we have selected using SPSS.
Hello Dr. Tan, my name is Muhammad Alif bin Muhammad Noor, and in my part, I just want to present you about sampling data and record categorical data. So if we look in a second slide, we can see they have a two of table here. First table show fuel consumption per 100 kilometers, and the second table shows a travel distance in a kilometer. So if we see in this two table properly, we can see they have two high line, which is the blue one color shows the highest value, and the green one color shows the lowest value of data. So in this part, we have a few steps to get a final answer. So the first step, we want to decide the number of classes. So in this syllabus, according to the syllabus, we must use the formula which is 2 power of k bigger than n. So 2 is a formula. So k it's bring the 6th value, and n is equal to 64. So 2 power of 6 bigger than 64. The final answer in this step, we get k equal to 6. Okay, second step, we want to determine the class interval or the class interval. So we have two parts. First, a fuel consumption, which is we use this formula, and the final answer we get a 1.308, and according to syllabus, we must round it. So the final answer round up. So the final answer for this part is 2. Same thing which is a travel distance. We use the same formula, and the final answer we get 3.26, and we must round up to get a 4. Okay, the third step is we want to set the individual class limit. So the third step was one of the challenges to do. So the minimum of data entry for liter per 100 is a convenient lower limit for the first class. To find the lower limit of the remaining 6 classes, add the class interval up to the lower limit of each previous classes. The upper limit for this part is 5.26, and the lower limit of the second class. The upper limit of the other class are 7.26. After add with a 2, the number will add with the next limit after complete the 6 classes. Okay. The minimum data for travel distance parts starting from the lower limit of the first classes. To find the lower limit of the remaining 6 classes, add the class with a 3 or with class interval 3.26 to the lower limit of each previous class. The upper limit class will be 7.26, which is 1 less than the lower limit of the second class. The upper limit of the other class are 7.27 plus 4. We can get 11.27 plus 4, so we can get 15.22 and so on. In step 4 was very easy because we just make a mark for every data we get. So the mark on the data that I mean is we can see in the slide number 5 and 6, because there has a class liter, tally and frequency. Okay, the total frequency we get 64, same number or value that I present you in letters. So in the slide number 6, the travel distance in kilometers frequency. So we have same thing, same item, class, tally and frequencies. The total value is still a same number, which is 64. And now we go to the way with relative frequency, which is relative frequency is the percentage of the data that fall in that class. So we have some of formula here that we use. Relative frequency equal to class frequency divided by sample size, which is n. So according to the slide number 7, you can see this data. They have a full consumption per 100. And last but not least, the last slide, you can see the data with detail, which is we have a class liter, frequency, relative frequency, and lastly cumulative frequency. So cumulative frequency, how we get it, we just add the value from the frequency, which is 0 plus 6, we can get a 6 plus 34, we get a 40 plus 22, we get 62 plus 1, we get 63 plus 1, we get 64. Same value with the frequency that we get from the step number 1, which is 2 power of k bigger than n. Okay, that's all for me.
Assalamualaikum warahmatullahi wabarakatuh. My name is Puteri SHAHIRA binti RAHMAN. My number matrix is A20A1914. I want to present the numerical descriptive measure. A measure of center is a value that represents the center of a distribution. Three most commonly used measure of tendency of one group and group, which is mean, median, and mode. For mean is the sum of value of each observation in the data set divided by the number of observations. It's also known as arithmetic average formula. So where x is mean point of the class, f frequency of the class, and n number of intervals in the sample. So the solution is 394 divided by 84. The answer is 6.154. So the mean of the full consumptions per 100 is 6.156. For the median is the middle value in distribution when the values are arranged in ascending or descending order. For the solutions, we can get the location of the median class is 32 observation. Therefore, the median class is 5/6. For the L is lower boundary, we get 4.5. When the C is the width of class we can get is 2. The cumulative frequency before the class median is 6. For the frequency class median is 34. So we use the formula and we can get the answer is 6.029. The answer. MOHD is the data entry that occur with the greatest frequency. When we use formula where the lower class boundary is 4.5, when the difference between frequency of model class before the class median is 28, when the difference between frequency model class after model class is 12, and the class size is 2. So when we use formula, we can get the MOHD answer is 5.9. 3.2 measure of position. Formula Q1 n over 4 and Q3 3n over 4. When we want to search Q1 and Q3, we use a formula that shown in the picture, and for in this case interquartile range is 2.139, which calculated by deducting with 7.227, deducting by with 5.088, and the answer is 2.139. 3.3 measure of variance. We have 3, which is a range, variance, and standard deviation. Range, we use formula range maximum data entry we plus with 0.5 and deducted with minimum data entry we lower with 0.5. So for the solution we get 12.5 deducting by 0.5, and we can get range answer is 12. For the variance, simple variance, we use formula, and we can get the answer is 2.17. For the standard deviations, we just use formula 2, and we can get the answer with 1.47.
Hi, my name is Siti HUMAIRA HUSNA binti ISNIN A20A1958, and I'm going to present about graphical representation, where it has two types of graph, which is histogram and ogive. Okay, as you can see, the first one is the histogram, and there are two histogram graph. One is for frequency histogram full consumptions, and the other one is for travel distance per 100 liter. Okay, class for this full consumption histogram is from 1 to 12, and to get the midpoint of this class, we add lower boundaries with upper boundaries divided by 2, and the resulting midpoint is 1.5, 3.5, 5.5, 7.5, 9.5, and 11.5. It can be seen at the graph that the most full consumption is at 5.5 per 100 kilometer, and the lowest is at 1.5 per 100 kilometers. Okay, we move to the next histogram graph, which is for travel histogram. Okay, the class is from 1 to 24, and the midpoint for the class after calculating according to the formula is 2.5, 6.5, 10.5, 14.5, 18.5, and 22.5 per 100 kilometer. And the lowest travel distance can be seen at 22.5 per 100 kilometer with only one frequency, while the highest is at 14.5 per 100 kilometers at 28 frequencies. Okay, for the next graph is ogive. Like histogram earlier, the ogive is also divided into two. One is for full consumption per 100 liter, and another for travel distance per 100 liter. Okay, for ogive, we use upper boundaries and cumulative frequency. And the class for this full consumption is 1 to 12. And the upper boundaries of each class is calculated by adding half of the gap value, which is 0.5 to the class upper limit. And the ogive below, we can see that it shows full consumption per 100 kilometer, and it can be seen that the highest total full consumption is located at 12.5 with a cumulative frequency of 64 per 100 liter. Meanwhile, the lowest total fuel consumption is at 2.5 with a cumulative frequency of 0. Okay, for OGIF travel distance, the class is from 1 to 24, and like fuel consumption frequencies, we use upper boundaries and cumulative frequencies. The cumulative frequency for travel distance is 1, 29, 33, 60, 63, and 64. The OGIF graph below shows vehicle fuel consumption with distance traveled in km per liter, and it can be seen that the fuel consumption with the highest travel distance is at 24.5 with the cumulative frequency being at 64 per liter. Meanwhile, the lowest amount of vehicle fuel consumption with distance travel is 4.5 with a cumulative frequency of only 1.
Hi and good evening to everyone. My name is Muhammad Irfan Iqbal bin Zahari. My matrix number is A20B1541. Today, I would like to present about statistical analysis using software. We are using SPSS, which is a software that using a method for statistical issues, and we wanted to have a comparison with a calculation in the SPSS and from calculation by hand. First, we go to the numerical descriptive measures. As we can see, the mean for liter per 100 is 6.4, median was 6.25, and mode was 7.14. When we look into the manual calculation for comparison, we can see that the mean is 6.156, the median was 6.029, and the mode was 5.9. So there is a slight difference at the mode calculation, which is about 1.27. In graphical representation, it is not having a difference between manual and that were created by SPSS. Next, we wanted to look into hypothesis analysis, and from the observation that we had, there is no significant difference among the treatments in ANOVA in liter per 100. In correlation analysis, we're using the Pearson's correlation to look into three variables: liter per 100, QPL, and weight. Based on the Pearson correlation analysis by using the SPSS, we have measured that determine the relationship and strength between the variables. A relationship occurs when changes of one variable tend to be go along with by constant changes in the other variables. From the study that we made, we measured the correlation between the liter per 100 and KPL. So we can see the R values between the liter per 100 and KPL is same. The R values between the liter per 100 and KPL is 0.941, both of it is greater than 0.5, which is near than 1.0. So we are looking into model summary. The R2 values, the R square value is 0.878, which means 87.8% of the variation. The value of adjusted R square is 0.876, which means 87.6% of the variation. Now we are looking to confidence interval. Confidence interval is a range of values within which the population parameter is supposed to exist. The 95% confidence interval can be rated to confidence level. Based on the result of SPSS above, the lower boundaries and the upper boundaries are 6.0945 and 6.5218 respectively. Also, it represents the standard error for this dependent is 0.11. So it can be said that we are in 95% confident that the population parameter is between 6.0945 and also 6.5218. Lastly, it is a prediction modeling. It is a multiple linear regression, and it is the most common form of linear regression analysis. As a predictive analysis, the multiple linear regression is used to explain the relationship between one continuous dependent variable and two or more independent variables. The dependent variables can be continuous or categorical, which means dummy coded as appropriate. The dependent variable may also be referred to as the outcome variable, so it also may be be referred to as the predictor variables. So based on the coefficient table referred to columns unstandardized p-value, the multiple regression model is negative 33.490 plus in bracket negative 2.679 liter per 100, which means equal as 30.81. So that's all from me. Thanks for watching.
For conclusion, we have concluded based on all data collected. For this stat, we collected all batches per consumption statistic data per 100 km with 393 operations. Based on data show that each year, this amount for firms use is different. This is due to many factors, while firms are used in different scales.